This article is related to design and simulation of robust fractional order adaptive control for nonlinear plants using MATLAB. So in this article, basically, I have just do the fractional calculus has been which is basically widely used in control system, and fractional order adaptive control scheme were used for nonlinear uncertain plants with external disturbances. And the adaptive law is basically designed to estimate the unknown parameters of the plant, and a robust control term is incorporated to mitigate the effects of disturbances. So the stability of the closed loop system is ensured through LAPNAV analysis. Simulation results basically provide us the complete effectiveness of the proposed approach in achieving the accurate tracking and robustness against the uncertainties and disturbances. Okay, so the differential equations have been used to model the various physical models. So the fractional calculus basically is a generalized for the classical calculus, and the proposed approach basically has potential applications in various fields, including the robotics, process control, and power systems. Abstract with the keywords, and the introduction is written in which the tracking error, in which state tracking, control input, control gain function, adaptive parameter, estimation, fractional derivative of error, nonlinear plant term, external disturbance, control gain function, phase plot, and the external disturbances are added in terms of robust fractional order adaptive control performance. So here is the adaptive control. I have just added the complete explanation, like the how fractional control stability and how its angle, its closed loop system is ensured through the LAPNAV analysis, and simulation results demonstrated the effectiveness of the proposed approach. Okay. So here is the nonlinear system and control challenges, which provide us the uncertainty plant parameters according to the its control gain, unknown dynamics, disturbance, state, and here is the fractional order control and its advantage is that it's turning and auto turning. Tuning and auto tuning of fractional order controls have been widely used in the modeling of system, in the dynamics, enabling the design for more effective using the control strategies. Okay, so here is yes, in the robotic process control power system, the LAPNAV functions for fractional order systems was used to nonlinear plant with uncertain dynamics and external disturbances, showcasing the robustness of the proposed approach. Okay, so the robust adaptive control and its challenges is that we have added its adaptive term, robust term, fractional term, total control according to the fractional order adaptive control scheme, which provide us the improved performance and robustness compared to traditional integer control methods. Okay. Problem statement is written. Mathematical approach is that how we have used the nonlinear uncertain plant according to in terms of equations, which we have used Gunvald, Letnick, Granvald. Letnick was one of the scientists who proposed a numerical approach for the fractional order adaptive control law, and the adaptive law also selected based on the different time domain equation closed loop system, which reduces the error ultimately, So this one is the methodology in which I have used the parameters of adaptive control system according to different stability of closed loop system ensured through lifetime analysis, which provide us the mathematical framework for analyzing the stability of nonlinear system. So the design and MATLAB simulation analysis is that in the MATLAB simulation we have just added like how the state tracking which is desired and actual. And desired means the red line dotted, and the actual means solid line blue line, which provide us some variations in terms of state tracking response. And the next one is the tracking error. This is the tracking error output graphs, control input graph provide us the post controller, and here is adaptive parameter estimator, fractional derivative of error, and as well as a nonlinear plan term. Next one is control gain function. Next one is robust control term, and external disturbances, as well as the plot phase versus x versus error. X means state and E mean error. Okay. So the results and discussions are here, in which we have added like how the performance valuation matrices, tracking error, and control energy convergence time as well. So here is a conclusion with the future work and references. Let me provide you the MATLAB demonstration of the project. Here is the MATLAB code for the complete system of the robust fractional order productive system. Let me just run it and you will get the output results accordingly. All the graphs, almost 10 figures are added in terms of different control stats like C plot, phase plot, X versus E, external disturbances, robust control term, control gain function, nonlinear plan term, fractional derivative of error, adaptive parameter estimate, control input, tracking error, state tracking. Okay, so I think it is okay now. If you need to ask anything, you just ask me. I will answer your questions. Thank you.